All right, so we're going to take a look at a couple of our old lessons. So let's start at 6.1. So 6.1, we talked about basically exponential growth is an introduction, and we're going to look at something that is near and dear to most people's hearts, which is finances. So we're going to talk about, in particular, interest and how it works. So way back when you first started talking about interest, like 6th grade, something like that, we would have had a couple things that we talked about. Our basic one is just things like taxes, simple percentages. So if we wanted to find 15% of 200, we would take that 200, we'd multiply it by 0.15, which is the percent as a decimal, and then that would tell us what the percentage is. In this case, that would be 30. So that's kind of what we did a long time ago. We're going to use something very, very similar. So we're going to talk about a whole sorts of different things. We're going to go over some vocab first. So as we talk about interest, compound interest, basic investing, finances, those kind of things, we're going to have a bunch of different things. So we have APR, which is our annual percentage rate. We have A, which is going to be almost always used as an amount, usually an amount after a certain amount of time. We have R, which is our rate. For the sake of this lesson, it's going to be our interest rate. And the main thing you have to remember is that R has to be given as a decimal. So 3% would be an R of 0.03. So make sure you have that. We have T, which is going to be time in years. Let's see, we have P, which is the principal, which is kind of the starting amount. So it's how much you owe to begin with on a loan or like your credit card, or it's going to be how much is initially invested in the case of a investment. So it's the initial amount. We're going to talk about N, which is the number of compoundings per year. Let's see, am I leaving off anything? No, those are our big ones. Okay, so let's start with simple interest first. So simple interest basically just follows kind of our simple idea of just multiplying a percent times an amount. So for simple interest, we have our amount is equal to the principal times 1 plus R. And simple interest is typically only going to be considered for 1 year. That's why it's such a short formula. If we wanted to talk about just the interest or the amount of interest that we generated, it would just be principal times the interest rate. So as an example, if we had a real simple like government bond or a COD or something, and we wanted to find out what it was, let's say we wanted to find out how much we would get after a year if we had a $1,000 investment at 8% simple interest, we would plug it into this basic formula for simple interest. So our amount would be equal to the $1,000 simple initial investment plus the 1.08, and then we'd multiply it through. So we'd have 1,000 times 1.08, and we'd end up with, what is that, 1,160? Yeah. So that would be all it is. Simple interest is really, really straightforward. If I asked how much interest it generated, it would be the 160, and we'd get that from just our 1,000 times the 0.08, which is 160. So the amount of interest generated was 160. The total amount in the account, if you put money back in, would be 1,160. That was simple interest. Honestly, there's not a whole lot of things to operate off of simple interest when we look at finances. Your basic sales tax is effectively simple interest. That's kind of the main one that you interact with. However, the one that really kind of makes the world go round is actually compound interest. Compound interest is how your credit cards deal interest. This is how your basic investments make money. This is how your mortgage is basically calculated. It's a little more complicated than that, but at its heart, it's still compound interest. Compound interest is really one of the big keys to wealth, and it's one of the big keys that will trap people in debt at the same time. So the difference between compound interest and simple interest is with compound interest, whenever they calculate how much interest there was, they immediately add it back into the amount, and then that lets it grow faster. So our basic formula for compound interest is A equals P times 1 plus R over N raised to the NT, where again, P is the principal, it's how much the initial amount is. R is the interest rate as a decimal. N is how many times it's compounded per year. And then T is the number of years. So let's just kind of look at a couple examples of this. So let's say that you owe $10,000 on a credit card. As an example, you refused, no, let's do an investment. Let's say you invest $10,000 at an interest rate of 8%, so 0.08, compounded monthly for 5 years. Oh, do I even have my calculator? That would be helpful. So if we invest $10,000 at 8% interest in an account that compounds it monthly for 5 years. Okay, so that's all the information we need. We can plug it in. So P is the initial amount invested. R is the interest rate. Those are the easy ones. N is the one I find people most often mess up. So the amount that we'd have in the account is $10,000 times 1 plus our interest rate of 8%, so 0.08, over N. If it's compounding monthly, what we need to do is ask how many times does that happen in a year. So if it's compounding monthly, then N would be equal to 12. So I plug in a 12, raised to the N times the number of years, 5. So this whole thing we can put into the calculator as long as you're careful with this exponent. So let's actually put that in, see what we come out with. You can double check your answer. So 10,000 times 1 plus 0.08 divided by 12 raised to the 60th power. So after 5 years, this $10,000 will have become $14,898.46. So that's how much you'd have in the account after 5 years. This is kind of the key for long-term wealth. If you can put money aside and invest it early on, it doesn't make a big difference for 5 or 10 years, but if you're doing this for a large section of your life, it's not difficult to have $1 million in a retirement account by the time you're ready to do so. The key is just to invest a small amount very early on and let it build for 30, 40, 50 years. By the time you're my age, it's a little bit too late, although you should still work really hard at it. The sooner you started, the easier it is. So as an example, let's say that we took $5,000, you get $5,000 as a gift from your parents, grandparents, whatever. We invested into an account that's going to return a pretty good 10%, compounded monthly. And you ignore that $5,000 for 40 years. Invest it when you're 18 and you come out when you're 58. Let's see just what would have happened if you just ignored that money. So again, we want to know how much money you'd have in the account after all that time. $5,000 is our principal, times 1 plus our 10% is being compounded monthly, raised to N times T, 12 times 40. Okay, so we go in. Again, this is just $5,000. It's not that much. So just by letting it sit there for a good chunk of your working years, that account ends up at $268,000, $503.32. So that simple $5,000 investment is now worth $250,000. The key is just length of time, honestly. And if you take something away from this class in regards to investing, invest early, and then let it sit there. Don't get greedy, don't take money out of it, just let it continue to slowly grow. So when we look at compoundings then, the more often that they put the money back in, the faster it grows. So we can look at some of the kind of standard compoundings that we look at. So kind of our standard ones are annual, so n would equal to 1, semi-annual, n would equal to 2. You could have things like quarterly, so 4 times a year, n would be equal to 4. You could have monthly, n is equal to 12. Daily, bake standard is 365. And then we can even go faster and faster and faster. So the theoretical limit to this is if we are compounding it instantaneously. It just keeps happening. Effectively, n is infinite. It happens over and over and over again as fast as possible. So all of these follow that same formula that we just used in practice. It reaches a mathematical limit that if you go further beyond this class, we'll talk about in like pre-calc or calculus, but this ends up being a different formula. So calculating continuously, we get our amount is equal to P times e to the RT, where e is just that a number. It's a transcendental number, it's 2.71, and goes on forever like pi. So this is how we would calculate something continuous. I'll do one example of that in a minute. So the more often that we compound, the more the money builds up and the quicker it builds up. This is why, unfortunately, sometimes your investments are only paid annually or quarterly, in the case of some dividends. Accounts are often compounded monthly. Credit cards, unfortunately, can be compounded daily, and then they just update it every monthly, or if they're a little bit older, they're not as savvy with what their computer systems are doing, then they might still be doing it monthly in general. So let's look at one example of the theoretical limit of how fast this can build. So let's actually look at that previous problem. So our $5,000 investment for 40 years would yield $268,503.32. So let's do the exact same investment of $5,000 at 10% for 40 years, but using the compounding continuously. So if we did that, that $5,000 times e to the 10%, so 0.10, times the 40 years. It's actually a simpler equation. Dump it right back into your calculator again. So 5,000 e raised to the 0.1 times 40. And we find that the theoretical limit to these would be $272,990.75. So the 6.1 homework is basically just practicing working with these conditions. Are you able to use each of the formulas based accurately on the information? And that's really what 6.1 was about. It's just getting used to the setups, knowing what the various ends are for compounding at different rates, and then practicing honestly using your calculator.